Okay, hopefully now you all feel used to methods, or at least you got a certain comfort level, at least in the understanding of them. Now let's go ahead and practice them. And we're going to practice these in a specific way, and that is using good code practices. So the first thing that you should do with methods is remove any methods that are unnecessary. And I would consider what we just did totally unnecessary, because all it's doing is saying hello and throwing up a message box. So let's do that. Let's get rid of all this stuff that we created. It was good for demonstration's sake, but it's not really worth keeping because it's not adding to our program or to the functionality of our program. Now, there's a lot of schools of thought on how to create a method. Some people base it on numbers of usable lines of code. So as you can see, this one goes from 27 to 36, about 10 lines of code there, right? Some people would say that's as long as you want to make. So don't count curly brackets or comments in these. Just count the usable ones. So I think I saw one that says don't use more than 25, so on and so forth. Another idea on methods is say just have them do one thing. And that always brings me back to my physics, mechanical engineering days, because we used to use this programming language called Fortran, which a lot of people make fun of now, but was actually a really good program language, and it still exists today. It's still got a lot of more ups than it has downs. But one of the problems with Fortran was we would write these what thing they call procedures, and procedures can take as many arguments as you want to put into them, and it would pass back as many variables as you wanted to go back, which was great, is super functional, but it created these super huge procedures. And that's actually the difference between a procedure and a function. A function is going to return something, but it can only return one thing. That's it. That's all it gets. So you can return an int, you can return a string, you can return a double decimal character, Boolean, whatever. It has that full ability to return anything, but only one of anything. With procedures, you can return anything you want. It's just a huge flow gate. And you can kind of think of it in this way. If you see a function in math, it's always y is equal to x squared plus x plus 5 or something like that, right? But there's only going to be one y on the left-hand side, right? Everything on the right-hand side is only going to pass back one piece of information back to the left-hand side. And that's the same with functions here. So anyways, getting back to the procedure thing, is because these procedures could flow so much information in and out, they became huge. And because we were, essentially scientists and engineers, that meant that we had to understand it, which was fine, because basically when physics and engineers get their hands on code, they will tell you, do not touch it unless you understand what the math is doing here. And that's a fair statement, so having these huge procedures, that was one method of doing it. But in today's programming, most people are work in their little boxes, let's say that, or you can almost think of it as a cubicle. I'm going to work, let's just say that's the introduction to our program, and someone else is going to do the database management, and somebody else is going to do the mathematics. We don't care what the other person is doing. We don't understand what the other person is doing, but we need to know what to pass in and to pass out. Right? That's all we need to know. So I'll say, okay, I'm going to take from my introduction the person's name and give it to the database person. How do I do that? And the database person says, well, this is the method you're going to use, and this is what you're going to pass into it. And you're going to get nothing back. It's going to be a void. That works. That's all we need to know. We can kind of treat that database person like he's a black box. And then the lady who's doing the math, we can treat her like a black box. And likewise, they can treat us like a black box, and it works a little bit better and more succinctly. So now getting back to my original point, when I make a method, I'm going to give it a useful name, and I'm going to give it to these people, and I'm going to tell them what to pass into it. And they're going to say, well, what does it do? Well, it does rescrambles words, says hello to somebody, does this. No, we don't want all that. Keep it as simple as possible in this case. So what you want to do is say, okay, no, this is all this method that I'm going to give you and tell you what inputs to put it in there. All that it's going to do is present your findings to a text box, to a label. Let's say a label, since we're using C#. And that's all you need to know. And that's all you want to do. You don't want it to do 4 different things, because they're going to see, well, what happens if I don't want to pass 4 things into this? What happens if I don't have 4 things available to you to pass into this from my host of methods? So keeping it simple helps. Keeping one function, I don't want to say function, because function, we've already defined it, but one duty per method works well. Okay, now let's keep that in mind, but I'm going to do one more thing before we get going, and that is delete these guys, because we never use them. So the less code you have, the less code you have to debug. Fair enough? Okay. So now we're back to where we were, and we have basically a bunch of setup, which does the initializations and the declarations. Then we have a try catch, which does the average, right? And then we have feedback to the user. So when you look at this try catch, that is one duty, right? So we already have multiple duties in this button compute. So why not just make a method that does this as well? And would we need to pass anything back? Let's see, we have to pass back average, right? Because we take this average and we're eventually going to use this average. So that's how we're going to build it. We are going to say average is going to equal compute. Oops. Did the autocomplete by accident? Compute average. And then what are we putting into it? Well, we can put the defaults in there. And in fact, we could just do test 1, test 2, and test 3. I guess that works. Because that's what we need in order to figure out this average. And the denominator, we have to pass that in as well, right? Denominator. And don't worry if you don't like this, you do not have to stick with this. Passing in a lot of variables is not the greatest thing in the world. It might have been better just to initial and declare these all inside of the compute average. So we have to decide at this point, should we do that? But I'm not going to do that. So let's just do this. And now we have to have a compute average. And a lot of times I'll just copy this and put it where I can see it originally, and then I can move it later. Like I said, I like to do mine in alphabetical order, but other people do different things. So, and the reason why I do it this way is because now I can set it up with the private. In this case, we have a return type, and the return type, if you notice, it has to match average. So average, where do we actually declare average? This is where we solve for average, but average is actually here as a double. So we have to actually say return type double compute average. And it still doesn't like it. We're still getting the squiggly lines because now that test 1 is not the same test 1. So I have to initialize these with the values coming in. And for some reason, I wanted that int denominator. I really don't want that int as a denominator. In fact, I don't want that as a constant int because we're going to play with that later. So let's do this. We're going to do that. I'm going to take this and change this into a double. And that should be good because now it's still giving me a curvy line, but notice it only gives me in one place. Well, actually two places because I haven't put the semicolon there. It gives me up here, not there, because what this is saying is you have a header, but you have no body. So let's go ahead and give it a body. And the reason why it's not working is because it needs to return average. So what we're going to do is we're going to say return average. And notice what I'm doing here. Oops, not compute average, just average. It wants a return. Wow, it really wants me to force me to do this. Okay, return average. But we've never established an average, so maybe we should pass average in. Yeah, I didn't want to be returning something that didn't exist, which makes sense. So now we're bringing all this stuff in. We got compute average. We're going to have to pass average in down here because good old C# is going to help me with that. But what it's saying is, well, average doesn't actually have a value. Well, in that case, let's do this. Because you're right, there's no average setup right now. All we have here is a declaration. So why don't we take this out? Because like I said, the more parameters you have, the more things can go wrong. So let's do average here, and we'll just call it double average. The reason why we're using double, if it makes sense, if you guys remember, because all these are double. So if we're going to use doubles to define it, why not call it double? And now we can go through, and believe it or not, this is where the easy part comes in. We can take all of this stuff and put that try catch statement right into this scope. Oops, into this scope. And it does the same exact thing as before, but now we've kind of cleaned this code up and given it a simple thing. Some people would argue, well, you're actually doing two things. You're solving for an average and you're doing a text output. That's going to be splitting hairs a little bit. If you want to throw that out, that's good. But again, like when you're working with others, they may only want you to spit out the average at this point. Because they might be taking their average in as a parameter to theirs, and they might not know what the GUI is doing at this case, and because they don't know what the GUI is doing, they might accidentally trample on your GUI, or there might be some like false output going to the GUI. So I would say at this point, this is where you kind of have to talk to people. Generally, if you're going to err on one side, I would say get rid of this and put this in its own piece. But today we're not going to do that. So now look at this. We've trimmed it down a little bit, still kind of huge, but at least we got something out of there, and we can always delete through there. And we're going to clean this up a little bit, and it should run. I don't see any errors at this point, so let's give it a try. Using that stepwise refinement, doing a little bit at each time. And I'm going to say, well, let's say this, 80, 80, 80, and hopefully our average is this. Great type. Oh, we're going to have to look this up. So this is another issue. Oh, we didn't pick a grade type. Okay, let's do that. So let's do 80, 80, 80, and I forgot which one we use. Oh, it says LB, which is short for list box. So we should have both of these selected. I don't know if you guys remember this, but we said back then we're going to eventually clean up and do one. So actually at this point, I think I'm going to do that. So let's go ahead and hit compute. Nice work. Your average is 80. You received a B. So everything's working correctly, and we can go on to the next step. And as you can see, some misplaced pieces. Are you sure it's a test? Are you sure that's a homework? I don't see the point in doing this. Like I said before, message boxes are great for giving information back, but they're really, I would say, use them more in the debug phase, except for when you have an error or something that you think the user is critically doing something wrong and you want to get their attention, or any specific attention. I think we also saw you should probably drop the course. You failed. Okay, those things are maybe not the nicest things, but those are their own pieces. Now, as you can see, average will show you the grade that they receive, and it will also show you the message that we received. And we can break this again down into simple pieces. In fact, let me check this one spot off. Yeah, here's some more message box that we really don't need. So let's get rid of this guy. And grade type string, and we're bringing in from a list box. So I guess what I'll do is I'll get rid of my radio buttons because they're redundant. So let's go ahead and delete those guys. Move this over, shrink this guy down, and we got a more compact form too, which is easier to read because the less things you have to look at, the less things you can forget to fill in, right? Okay, so now let's go back into the compute button, and now I'm going to go the opposite way. So like I said before, this right here, it should be its own piece or method. So I'm going to call this method feedback. We're just going to call it void feedback. In this case, we'll allow the message box because it's a nice little thing. So void feedback, and then we have to bring in, as you can see, the only thing we have to bring in is grade. So we're passing in grade, and since it's void, we don't have to set it equal to something or put it in something, if you notice that. Oh, in fact, I don't even want void at this point. So if it's returning something, you have to use an equal sign or put inside a parentheses of something else. But here, feedback grade is just going to do something, so it's not going to pass it back. We don't need to do anything with that information. And likewise, like I said before, I love doing this because it makes things easier when I do feedback grade, and then that, all I have to do is put in double, because I believe grade was a double, and then I can do void grade, void feedback. Now, if you notice we didn't put the private there, if you don't put the private there, it's going to make it private. Out of habit, though, because most of you will be doing lots of programming languages, they don't always default to private. It's important that you kind of get used to that. Just and kind of plan that out, get you to plan that out, because some stuff you do want to be public and some things you do want to be private. So let's match those to the correct thing, and then that will force us to have a good game plan as well. And just like last time, we're done, right? We just grab this whole guy, copy, paste it in here, And that's it. Now we have to trim one more thing back. We'll call this guy, this one isn't feedback. We'll call this, and we're passing an average this time, but we're getting the grade back, right? So we're getting grade. Oops. Speaking of which, grade is not a double, grade is a character. So let's go ahead and make sure that is correct. So we're bringing care feedback. In fact, let's go ahead and test that out just to see if there isn't. Oh, we have a missing semicolon. Yes, we do. That's because I just typed it. Okay, start it again. 80, oops. All right, we'll do 880s and might get homework this time. And it looks good. It's happy with that because we got plenty of extra credit. So we're good. We're good. Okay, so let's go back to this last part and average. We're going to pass in. I'm going to say I'm going to call this one form feedback. How about that? So we have a grade equals form, and let's make it capitals. Form feedback, and we're going to bring in average. Makes sense? It gives me a squiggly line because I haven't created form feedback, but this is what's going to happen. Since I have to bring in average so I can pump it into these ifs and else statements. But I have to get grade back into here, right? Because it's going to give this grade, and then this grade is going to go into the feedback method that we just created. So we need both input and output on this one. And like one more time, I'm going to put form feedback, and I'm going to put it after this. Excuse me, I'm going to put it after this. So in this case, I'm going to say private, and I'm going to put care because it's returning a character, and it's bringing in average as a double. And then we're going to make it a blank method. But notice that even though form feedback, and actually I'm breaking convention here because really I should put a big F here as well. This is dependent on how you're planning on doing it versus camel casing versus Pascal casing versus a bunch of other different ways. But let's say everybody agrees that all methods are going to be capitalized. So let's just say that. And now we have form feedback and feedback capitalized. And notice form feedback comes first in the actual button method, but that doesn't necessarily mean it has to come first in the definition. In the function definition. So as soon as this does a callback feedback grade, it's going to look for feedback here and then run this. And then run this guy. Same thing here. It's when I go to form feedback average, it's going to look for form feedback average. Say, oh, that's not there. Oh, here it is. Okay, I'm going to run this. It doesn't care that they're not in order. It will your compiler will align all those up for you. All right, so we have grade, form feedback, average, and the only thing that we have to do here for form feedback is return grade, which we have not established yet. So let's do care grade. Still not going to like this because we've only initialized it. it auto-completed on me, so let's put the right word in. So it's not going to like this because, hey, you don't have anything planned, but don't worry, we're going to copy. And we're going to paste. Control X. Let's Control V in here. And now we have the grade being established. It's going to get returned. And let's look at now our original function. This should look pretty nice now, right? We just have some very simple things. We have a function call here, or excuse me, a method call here, a method call here. Actually, technically, you could call these functions because they are returning something. But we'll just call them all methods at this point. Method here, method here, method here, and then we're going to keep all that stuff straight. And we sizably decreased this button compute click method. And all these methods, as you can see, are not huge. This is probably the biggest one. And the reason why is it's got a bunch of else, ifs, else. If we were smart, we could fix that with a switch statement or something like that as well. So that all works. So let's go ahead and give this a quick start just to make sure it's still working. And again, we'll do our 80, 80, 80. I suppose we should pick different numbers because what happens if there's a flaw and it always returns 80. But there we go. We hit test. Your average is a B, and nice work. Everything is to snuff. And hopefully that is going to make a little bit more sense when it comes to practicing methods and the understanding of methods. If you do not understand what I did, rewatch this video. That is the best thing that you can do, because and work along with it. That's probably actually that's really the best thing. Work along with it and then redo it, and then you will find you'll understand it the more you see it. Because really all this is now, when you're learning methods at this point, is practice. Getting used to taking the leap of faith that it's actually going to do the right function call, and you're actually going to pass the right variables, and the right things are going to get returned. And if they don't, guess what? You debug, you fix it. Don't take those big steps, do that stepwise refinement, and just keep going with it. All right, good luck.